Hi, welcome back to our Honors Geometry playlist. On this video, we're going to do our 4.7 and 4.8 notes. These are on geometric transformations and on our geometric proofs in a coordinate plane. So both of these deal with our coordinate plane. Now what I would encourage you to do is to pause the video, take down these definitions, unpause, check your work, right? Make sure everything is copied down correctly. And once you got your definitions copied down, we can move on. So I have three different types of transformations that are rigid or congruence transformations. And those three types of transformations are rotation, reflection, and translation. Whether you're turning the shape, if you're flipping the shape over a line of reflection, or if you are translating or moving or sliding the shape. So I want to identify what type of congruence transformation is going on here. Well, in this first problem, it looks like this shape is being turned. So I've got a rotation. What I would encourage you to do is pause the video, identify what kind of transformation is going on in the next 5, and then unpause and check your work. It looks like that second one is a reflection. And if I were identifying what kind of reflection that is, it seems like it's a reflection over the x-axis. That looks like a translation because the shape did not turn in any way, it did not flip. It looks like everything moved very nicely in the same direction, the same exact amount. 1A, it looks like I have another reflection over the x-axis. This looks like a rotation. And then 1C appears to be a translation again. And the reason why I'm looking at my rigid transformations now, these congruence transformations, is because we've just finished up our chapter on congruent triangles. So in our congruent triangles chapter, we found a bunch of different ways, whether it was side, 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 or side, angle, side, or angle, side, angle, angle, side, hypotenuse, leg, or even before that, when we proved that all the corresponding parts were congruent. We found a bunch of different ways to prove that things are congruent. Well, if you're looking at congruence transformations, another way to prove congruence would be to say that one shape is a transformation of another by a reflection, rotation, or translation. And if I can show that one shape is a reflection, rotation, or translation of another shape, or that I can get from one spot to another by doing a translation, rotation, or reflection, then I can show, or I have shown, that those two shapes have to be congruent. So for example here, I've got triangle ABC, 1, 3, 1, 1, 4, 1. So there's triangle ABC. And then I have triangle DEF, 3, negative 1, 1, negative 1, and 1, negative 4. And I'm hoping to show that one triangle is a translation, rotation, or reflection of the other. So if I could show that ABC, if I rotate it, becomes DEF, then I would have a congruence transformation. So I have triangle ABC. It looks like it is a rotation of, and well, if I rotated this from one quadrant to the next quadrant, it looks like it's a rotation of about 90 degrees, or 1/4 of 360. Now, if I wanted to prove that these were a congruence transformation, I could prove this by side, side, side. If I were to show, for example, that this side is 2, this side is 2 units long, BC is 3 units long, DF is 3 units long, and then I could use my Pythagorean theorem to find the third length, which would be the square root of 13 and the square root of 13. So it looks like a rotation of 90 degrees, and I could also prove that it's still congruent if I found all 3 side lengths. 2 of them I could just count, 1 of them I had to do a little bit more work. Let's try another example. Triangle XYZ with x 2, -8, y 4, -2, and z, which was 6, -7. This is x, that's y, there's z, and then I have another triangle here, ABC, with vertices of 2, 8, 4, 2, and 6, 7. I want to know what transformation would take me from my pre-image, the first shape, up to the image. What transformation could I do, a reflection, rotation, or translation, that would get me from the pre-image to the image? And it looks like it's probably a reflection over the x-axis. Right, if I flip it over that line, it looks like that would probably be a reflection over the x-axis. And if I wanted to prove that those are really congruent, I could use my distance formula to find all 3 sides for my image and all 3 sides for my pre-image, and they should be congruent. All my corresponding parts could be congruent, so I could show by side, side, side that those triangles really are congruent. Okay, so that's sort of the basics. There will be a 4.7 part 2 coming up here, and then I'll drop the 4.8 notes later today.